Good morning. Myself, Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is static CMOS design from the unit 2 combinational logic circuit in the subject of VLSI design. Let us discuss. Okay. CMOS. A static CMOS design refers to the implementation of digital logic circuit gates using CMOS technology. It is characterized by the use of both PMOS and NMOS transistor to create a logic gate that has low power consumption, high noise margin, and a reliable performance. Complementary structure. Here you can see the diagram. First we have to connect PMOS, and second serially connected with NMOS. PMOS is nothing but the pull up network, and NMOS is nothing but the pull down network, and gate terminal of the both two MOS transistor input to connected to the gate terminal of the both these two MOS transistor, and output get from the drain terminal of these two MOS transistor, and source of the pull-up network is connected to the VDD, and source of the pull-down network is connected to the VSS. These used to pull up the output high, which means logic 1, and used to pull the output low, which is logic 0. The combination ensures that at least one of the transistor is off at any given time, minimizing direct current from supply to ground. Next, we will discuss the power consumption. Static CMOS circuit consume very little power during steady state operation because there is no direct path from the supply voltage to ground except during switching. And next one is noise margin. Static CMOS design typically have high noise margin, making them robust against variation in voltage, temperature, and process. And another one is no static power dissipation, because unlike a dynamic circuit, static CMOS gets only consume power during transition. There is no continuous power dissipation when the circuit is in steady state. CMOS technology scales well with process advancement, allowing for the creation of increasingly small and faster circuit. Already we have discussed. Next. Here we can see the some of the example of static CMOS NAND gate, which involves creating a circuit that outputs a low signal only when all input are high. The CMOS NAND gate uses both PMOS and NMOS transistor in a complementary fashion to achieve this behavior. Two, here you can see two input NAND gate with which is A and B. Two input NAND gate. The Boolean expression for a two input NAND gate is y equal to that means output equal to complementary A into B, and the output Y is high unless both input A and B are high, in which case the output Y is low. Transition level implementation. PMOS network. PMOS transistors are used to pull the output high. For a NAND gate, the NMOS transistors are arranged in parallel. If either A or B is low, at least one PMOS transistor will be on, pulling the output Y to high. And NMOS network. NMOS transistors are used to pull the output low. For a NAND gate, The NMOS transistors are arranged in series. For a NAND gate, the NMOS transistor arranged in series. Both A and B must be high for both NMOS transistor to contact and pull the output Y2 low. Here you can see the PMOS transistor. How the transistor are connected for a two input CMOS NAND gate. PMOS transistor connected in parallel. The sources of both PMOS transistor are connected to the supply. The drain of the PMOS transistor are connected together and to the output Y. The gate of the PMOS transistor are connected to the A and B respectively. And NMOS transistor, two NMOS transistor are connected in series. The drain of the NMOS transistor are connected together and to the output Y. Here output OUT. Okay. The sources of the NMOS transistor are connected to the ground and the gate of the NMOS transistor are connected to the A and B. A and B means input. And let I discuss the working of of this circuit. First case. Here you can see the truth table. Case 1, A equal to 0, B equal to 0. Both PMOS transistors are on, pulling the output Y to high. Both NMOS transistors are off, so there is no path to ground. On means conducting, off means non-conducting. Okay. And in the case 2, A equal to 0, B equal to 1, or case 3, or A equal to 1, B equal to 0. One PMOS transistor is on, pulling the output Y to high, which means logic 1. One NMOS transistor is off, so there is no path to ground. And another case is A equal to 1, B equal to 1. Both PMOS transistors are off, so they don't pull the output high. Both NMOS transistors are on, creating a path from the output Y to ground, pulling the output Y to low. The CMOS NAND gate design uses complementary arrangement of PMOS and NMOS transistor to create logic function that is low to only when all input are high. This is a key component in digital circuit design due to its low power consumption and high reliability. Yeah, static CMOS design is foundational in VLSI and forms the basis of almost all modern digital logic circuits, for simple logic gates to complex microprocessors. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.